Learning outcomes of this video are, for example, if you want to know the real concept of the tear lens, if you want to know the real calculations of the over-refraction and the final power after the effect of tear lens and over-refraction. So if you want to know about the different calculations, the real numerical and mathematical calculations of the RGP lenses, stay with me till the last moment of this video. Hello, this is Khurram Nasir and you're watching Optometry with Khurram, and today's topic is about the tear lens, the real concept of the tear lens. People think whenever they deal with the RGP lens, they think that there is only one lens which is placed inside the eyeball over the cornea, and that is RGP lens. But this is very wrong. Whenever we deal with the RGP lenses, there are three different lenses which are placed in the eyeball. Number one is called the itself cornea. Cornea is a lens which is carrying the specific and particular power, right? And the second one is called the RGP lens, right? This is cornea and this is RGP lens, and RGP lens is draped over the cornea like this, right? So two. And the number three, the lens which is between the cornea and the RGP lens, and that is called the tear lens, right? And in specifically RGP lenses, the tear lens have a clinical significance and optical significance, right? This is very important. So, but depends that either the tear lens which is between the lens and the RGP lens, between the cornea and the RGP lens, has a plus effect or has a minus effect. That situation depends on the fitting of the lens. Either the fitting of the lens is steep or flat or alignment fit, right? For example, if there is a compatibility between the cornea and the RGP lens, there will be a least or there will be no any the tear lens, right? And there will be a least spherical tear lens when there will be a compatibility between the lens, RGP lens and the cornea. But when, for example, there is a steep fitting or there will be a flat fitting, and let's understand, for example, if there is a steep fitting, right? And in the previous video, in part 2, we have discussed about the steep fitting and the flat fitting, right? So steep fitting, very well, there is a, for example, if there is, this is cornea and this is RGP lens, and in steep fitting, these are edges or periphery of the lens of the RGP lens, right? And in steep fitting, it will look like this. The situation will look like this. The edges of the cornea, the edges of the RGP lens will fixate over the cornea, and there will be more space between the lens and the cornea, right? So a fluorescent or tear will accumulate between the lens and the cornea, right? That is called the tear lens, right? So if there is a steep fitting, it will look like this, right? There will be a more gap placed between the lens and the cornea like this. As you see, this blue marker is representing the cornea and the eyeball. This is cornea, the blue marker, and this red line is representing the RGP lens, right? So as you can see, there is more space between the lens and the cornea, this space. So actually it is giving the effect of a plus power like this, right? So for example, if fitting is steep, then the tear lens will be in plus form, right? Because there is more space between the lens and the cornea at the center, and very well, the plus lens is thick at the center like this. So for example, I'm writing it down. In steep fitting, the tear lens will be plus form, right? And in contrast, if we discuss about the flat fitting, right? In flat fitting, very well that there is no space at the center, right? For example, this is cornea and this is RGP lens, and it will look like this. At the center, at the apical place, there will be no any space between the lens and the cornea at the center, but there will be more space between the lens and the cornea at the periphery, at the edges, right? So very well that it will look like this. There is no space between the lens and the cornea at the center, at this place, and there is space between the lens and the cornea at the periphery. So it will give the effect of a minus lens. So whenever there will be a flat fitting, the tear lens will be in minus form. So we have discussed about the positive tear lens and negative tear lens. As I said that whenever the fitting is steep, there will be a tear lens and that will be in plus form, right? And whenever there will be a flat fitting, there will be a tear lens and the power of the tear lens will be, in flat fitting, the minus, right? So to compensate, the tear lens is not a good thing. Remember, the tear lens is not a good thing. I won't feel proud that I have a tear lens between the lens and the cornea. The tear lens is not a good thing, right? If the tear lens is there, if the maximum tear lens is there, it means your fitting is not good. your fitting is not aligned, right? So to neutralize that tear lengths, we have a rule that is called SAM and FAP. This is SAM, right? Whenever there will be, SAM mean steep fitting, SAM means steep. If the fitting is steep, then you have to add minus, right? Steep, add minus. And for example, if you have a flat fitting, then you have to add flat, add positive or plus, right? This is the rule to neutralize that tear length. For example, assume that we are having a base curve in diopters, not in millimeters. I will give you an example in millimeters base curve as well, right? So for example, if we have a base curve of the contact lens is 43 diopters and power is minus 3 diopters, and when I observe after the fluorescent phenomena, I decide to steep 0.5 base curve, right? I have to steep after the fluorescent phenomena. I decide that I have to steep the base curve. And what is the value of the steepening? The value of the steepening will be 0.5, right? And you know very well, what does it mean when we say steep? I have told you earlier that in steep fitting, there will be a tear length. And what will be the power of the tear length? In steep fitting, the power of the tear length will be plus. So it will make a positive tear length. Whenever I will steep 0.5 base curve, steep mean positive tear length. So it will make positive tear length, right? To neutralize that positive tear length, I have to apply SAM rule. SAM mean if the fitting is steep, right, I have to add minus, right? So the total power is minus 3, look, and I have to add minus. So I will add minus 0.5, right, base curve in the minus 3, right? So plus minus will be minus and minus minus will be minus. So the total power will be 3 and 0.5 will be 3.5. So for example, if the base curve is 43 diopters, power is minus 3, and I decided to steep the base curve, and steepening will cause positive tear lengths, and to neutralize that positive tear lengths, I have to add minus according to the SAM rule. So the final power will be minus 3. And let's discuss about the FAP rule. In FAP rule, for example, I have a calculation, a base curve which is 43 diopters, and the power of the lens is minus 3 right now. And after fluorescent phenomena observation, I decided to flat the base curve 0.5 diopters, right? I flat the lens 0.5 diopters. I flat actually the base curve of the lens, right? And what is the value? 0.5. So you know well, flattening of the lens cause the tear length, and what will be the sign of the tear length? Minus, because flattening cause minus tear length, right? So flattening is there, and if flattening is there, I have to add positive, because flattening lens or flattening of the lens cause minus tear length. To neutralize that minus tear length, I have to add plus, right? So total power was minus 3, and I have to add 0.5, right? I have to add plus, and plus will be plus, and plus and minus, the minus sign is with minus 3, and positive sign is with 0.5. So minus and plus will be minus. So I subtract plus minus minus in algebra. So I will subtract 0.5 from the 3, and the answer will be 2.50 diopters. So the resultant power will be 2.50. And now let's understand the same method but with different unit of the base curve. Like for example, if we have base curve not in diopters but in millimeters, right, 7.8 millimeters, right, then we will solve the same examples, right? But before that, you have to learn a simple concept. For example, if your base curve is in millimeter, and you want to change the base curve of the lens, then it will affect the power, the dioptric power of the lens as well. Remember, for example, if you change the base curve which is in millimeter, if you change the base curve from 0.05 millimeter, you change the base curve 0.05 millimeter, and it will change the power of the lens as well. And how much? 0.25 diopters. And if you change the base curve like 0.10 millimeter, it will change the power 0.5 diopters. And if 0.15 millimeter, it will change the power 0.75. And if you change the base curve from 0.20 millimeters, it will affect the power or change the power 1 diopters. This is the basic rule you have to remember, right? Now let's discuss the example. So for example, we are discussing the SAM rule, right? For example, if the base curve is 7.8 millimeter, power is minus 3 diopters, and after fluorescent pattern, you decided to change the base curve, right? 0.05 millimeter. You decide to change after fluorescent. You observe something and you decide you have to change the base curve. And how much? 0.05 millimeter. You have to steep your base curve. And what is the value of the steepening? What will be the value of the steepening? 0.05 millimeter. And you know very well, the steep fitting will cause positive tear lengths, and it will cause positive tear lengths, positive, right? And we know that if base curve is changing 0.05 millimeter, it will change the power 0.25, right? Positive. Why positive? Because there is steepening change in the base curve, right? So positive, it will cause a positive tear lengths. So to neutralize that positive tear lengths, I have to apply SAM rule. SAM mean if the fitting is steep, I have to add minus. So power is -3, I have to add, minus. So I will add minus 0.25 to neutralize that plus 0.25, right? And my resultant value will be minus 3.5. How? Minus 3 plus minus minus, right? And minus, minus 3 and minus 0.25, algebraically it will add, sum up, right? So 3.00 and 0.25 will become minus 3.25. So that will be the resultant power of the lens you have to prescribe. And now the same example with the FAP rule. Remember, for example, the base curve is in millimeter, 7.8 millimeter, and the power will be -3. And after fluorescent, after observing something, after fluorescent phenomena or fluorescent, observations, you decide you have to flat your base curve, and how much? 0.05 millimeters, right? And you are flattening the base curve actually, and you know very well that in flattening, a tear lens becomes or produced, which is minus tear lens. Flattening always gives minus tear lens. And value of the base curve, value of the change base curve is 0.05, right? And if base curve is changing 0.05, it will give minus 0.25 of the change in the power, right? So the tear lens is minus. I have to neutralize that minus tear lens. And how? With the FAP rule. For example, the total power is -3, and I have to add plus, right? Why plus? Because to neutralize that minus tear lens, right? So plus and plus plus, and -3 and plus 0.25, right? And after that, the 3 has minus sign, 0.25 has plus sign, and plus and minus will be minus. So I will subtract 0.25 from the 3, and the answer will be minus 2.75. So the resultant power will be minus 2.75. Now let's discuss about the very important phenomena which is called the over-refraction, right? You give the best total diameter, you give the best base curve, you perform the fluorescent patterns, and you give a best fitting to the patient, best fitting of the RGP lens. And after that, a point comes that is called the over-refraction. For example, you put or insert or placed RGP lens on the patient's cornea, right? But the visual acuity is not good still, right? It's not 6/6, and you have to give the best visual acuity, and that power, that lens which is placed, that RGP lens which is placed inside on the patient's cornea, over the patient's cornea, that doesn't have a complete power, right? But you have to give additional power in the form of the trial lenses, and that lenses are called, and that refraction is called the over-refraction. And how does it works? For example, you placed the lens, the RGP lens on the patient's cornea, over the patient's cornea, and to make the better visual acuity, to make that patient 6/6, right, you will add some trial lens over the contact lens, and that refraction is called over-refraction. So I'll make you understand with the numerical example. For example, if the ocular refraction or the total refraction which is required by the patient is -6, right, but you doesn't have -6 diopters of the trial RGP lens, and you use, instead of -6, you use the trial lens which is -5, right? And the corneal curvature, you have corneal curvature as well. You can have the corneal curvature with the help of the keratometry, very simple, right? And the corneal curvature is 43 diopters, and the base curve of the lens, which lens? The RGP lens, the trial lens, which is having the -5 diopters of power, and the base curve of that trial lens is 43.5 diopters, right? So first I will make you understand that how can we calculate the power of the tear lens. For example, tear lens is there, tear lens is produced between the lens and the cornea, and how much power, right? So you can calculate the power of the tear lens with the help of the two different factors, and those factors are, number one is called the corneal curvature. You have to have corneal curvature, right? And you can get that corneal curvature with the keratometry. And the second one will be, you have to have the base curve of the lens, the base curve of the trial lens. If you have these two values, you can easily find out the power of the tear lens, right? How? So tear lens, you have to deduct corneal curvature from the base curve of the lens, right? So we have base curve of the lens, that is 43.5. We have corneal curvature, which is 43, and we will subtract corneal curvature from the base curve, the resultant value will be plus 0.5. So the tear lens is in plus form. And if the tear lens is in plus form, it means, you know very well, plus tear lens always form when the fitting is steep, right? So now we have to find the effective power. And what is effective power? We have to calculate the total power of the whole media, like the tear lens, like the trial lens and all, right? So we have to find the effective power. How? We have to add, we have to, sum up the trial lens as well as the tear lens, right? So I have trial lens and I know the power, that is -5, right? So I will write -5, which is a trial lens of the contact of the RGP lens, and I have a tear lens as well, and I know the value, right? And that is 0.5 diopters, right? So -5 plus and plus plus. So -5 minus sign is with 5, plus sign is with tear lens 0.5, minus and plus plus, sorry, plus and minus minus. So I will subtract 0.5 from 5, and answer will be minus 4.50, and that 4.50 is my effective power, right? But I required -6, and I have only 4.50. So how comes the additional power? With the help of the over-refraction. And this is over-refraction. So I have total power, the requirement is -6. I have -4.5 in the form of tear lens and in the form of, the trial lens, and then I will perform over-refraction, right? And how come the over-refraction? If I subtract, -4.5 from 6, the resultant will be 1.50. So that 1.50 I have to give in the form of the trial lenses, and that is called the over-refraction.